Today, we are diving into a hidden battle, one that happens every single day inside our hospitals and labs. It's the constant fight against infectious waste. We're going to look at some really cool research that puts everyday chemicals to the test against nasty bacteria, all in a quest to find a safer and cheaper way to keep all of us healthy. I mean, you walk in, you see the cleaning carts, you smell that distinct disinfectant smell, but what does it actually take to get rid of dangerous microbes? It is a super important question because in healthcare, clean isn't just about how things look, it's literally about saving lives. You know, every single day, hospitals and labs create tons of waste that could be infectious. And dealing with that safely, well, it's a huge logistical and financial headache. And as our healthcare gets more advanced, this problem just keeps getting bigger. To put a number on it, treating just 1 kilogram of hazardous medical waste, that's about 2.2 pounds, can cost almost $4. Now, imagine that on a global scale. Yeah, those costs get astronomical, fast. So you can see why finding a cheaper, effective solution is such a massive priority.
Okay, so this exact challenge is what got a team of researchers in Brazil thinking. They wanted to figure out if common, pretty inexpensive chemicals could be the answer to this very, very expensive problem.
So let's meet the heroes of our story. This work was led by researcher Alessandra Matavel and her team. They're based at the Fundación Ezequiel Diaz, that's the Ezequiel Diaz Foundation, in Belo Horizonte, Brazil. And they set out to really test and validate different ways to clean up lab waste right where it's created. They picked 5 well-known chemical workhorses for this fight. You got your basic bleach, hydrogen peroxide, the very powerful but also pretty toxic formaldehyde, regular old ethanol, and something called quaternary ammonium, which is a key ingredient in a lot of cleaners you have at home. The stage was set for a real showdown.
The whole experiment was set up as a head-to-head competition. How would each of these chemicals actually stack up against a super common, well-understood bacterium?
Now, to keep score, the scientists used something called LC50. The easiest way to think about this is its knockout power. It's the absolute minimum concentration of a chemical you need to kill half the bacteria in a sample. So here's the key. The lower the LC50 number, the more powerful the disinfectant is. Less is more in this case. And the opponent in this big showdown? A specific lab strain of E. coli. It's considered low risk, and it's used in labs all over the planet, which makes it the perfect punching bag for a test like this. And wow, the results were pretty clear. What this chart shows is how much each chemical could be watered down from its original strength and still pack a punch. A higher bar means more power. And as you can see, formaldehyde was the undisputed champ here, with hydrogen peroxide coming in a strong second. Looking at the hard data is even more interesting. Formaldehyde had this teeny tiny LC50, which means its stock solution could be diluted more than 2,000 times and still work. Hydrogen peroxide was also a beast. But then you look at the other end of the scale. Ethanol needed a much, much higher concentration. It could barely be diluted at all, less than 1 to 8. But, you know, killing bacteria that are just floating around in a test tube, that's one thing. The real world is a lot messier, right? It's got surfaces, like gauze, bandages, and all sorts of lab equipment. The team knew they had to push their tests into a more realistic setting. So that's the million-dollar question. Does the champion of the test tube still win in the real world? This is where research gets super practical. The team soaked pieces of gauze in the E. coli bacteria and then hit them with the disinfectants. And what they discovered can pretty much be summed up by this one really important number: 5. This is a huge deal. What they found was that to completely wipe out the bacteria on a solid surface like gauze, they needed a concentration 5 times higher than what worked in the liquid tests. It just goes to show you, context is everything. What works in one situation needs a major power-up for another. The researchers also stumbled upon this fascinating and super practical detail about a disinfectant we all have at home: bleach. Get this, after just 8 weeks sitting in a clear bottle exposed to light, the bleach lost a jaw-dropping 79% of its power. But the bleach they kept safe from light in a dark amber bottle, it only lost 17%. The lesson here is crystal clear. Store your bleach in the dark.
So, what does this all add up to? How can this showdown in a Brazilian lab actually help create smarter, safer cleaning rules for all of us?
All right, let's recap the big points. First, you don't always need some fancy, expensive chemical. Common stuff works really well. Second, and this is crucial, context is king. You need way more disinfectant for surfaces than for liquids. Third,
When you balance power, cost, and safety, good old bleach comes out looking like a fantastic choice. And last but not least, how you store that bleach makes a world of difference.
At the end of the day, this research is basically a roadmap. The authors themselves said it best. The whole point was to find simple, low-cost methods that can boost health and safety, especially in places that don't have a ton of resources. It's all about making safety accessible for everyone. And that kind of leaves us with a final thought to chew on. This whole study found incredible insights just by taking a closer look at things we see and use every day. It really makes you wonder, what other simple, powerful, life-saving solutions are just sitting there, hidden in plain sight, waiting for us to find them?